Hi, it's Mr. Anderson, and this is AP Physics Essential Video 4. It's on the atom. In the last video, we talked about how Ernest Rutherford and his gold foil experiment had helped scientists discover this positive small nucleus in the center of an atom. But that didn't tell us what the electrons were doing. And he just speculated that they were moving around the nucleus almost like planets in orbit around the sun. But one of the researchers working underneath Rutherford, Niels Bohr, spotted a problem in this. He knew that any charged particle that's moving is going to be giving off electromagnetic radiation. As it does that, it's losing some of that energy, and so it's going to quickly spiral into the middle and annihilate essentially the whole atom. So he knew that wasn't right. He also knew that as it gives off radiation, the wavelength of that radiation is going to vary. And as it varies, we're going to get this nice, smooth spectrum of electromagnetic radiation given off by high-energy atoms. But when we started to look into space, what we found is that light wasn't smooth. It had these discrete units within it. And so that spectra had to be described. And Bohr's model helped to do that. And so if you think of it like this, and this works for hydrogen, is what the Bohr model is built on. You have these energy levels. And so an electron can be in energy level 1, energy level 2, energy level 3, but it can never be found in the middle. It's quantized. It has to be in one of those levels or another level. And so how does it move between levels? Well, if it absorbs energy from a photon, electromagnetic radiation, for example, it'll jump to a higher level. And as it moves down, it's going to emit those photons. And that helped to describe what we were seeing in the spectra. And so that improved our model. So we now had the cloud that had the electrons in it, and then the nucleus. And so we found these negative electrons in the cloud, and then protons and neutrons were found in the nucleus. And in a neutral atom, the number of protons and electrons are going to be equal. And the electrons tell us a lot about the properties of that atom. In fact, the whole periodic table is built on the electrons. Electrons especially we have in these outer levels. Now, the Bohr model helps us explain what those electrons are doing and how they're moving. They move into these discrete energy states, and that helps us to explain the spectra. And so if you look at any kind of an atom on the periodic table, the atomic number 2 tells us the number of protons we have. And so we're going to have these positive protons that are going to be found in the nucleus. We can kind of figure out how many neutrons roughly we're going to have in an average atom by taking the mass number, subtracting the atomic number. And so we would know in helium, for example, that we're going to have 2 neutrons. Now, since the number of protons and electrons are the same in a neutral atom, we can figure out that we've got these electrons moving around the outside. And the number of electrons that we have out there tell us a lot about the properties of the atom. And so if you look at the periodic table, this whole thing is essentially built on the number of electrons that we have, because that tells us a lot about the properties. And so if you look right here, we'll find copper, silver, and gold, which are all very similar, are in the same column. And that essentially says that they have similar outer level electrons. Or if we look in the first column, all of these are highly reactive, all the noble gases are not, and so the properties of atoms are built on those electrons. But there were problems with this planetary model. Electrons weren't orbiting like planets. They were actually jumping between orbits, according to Niels Bohr. And so they didn't just move back and forth on all these infinite number of orbits around the nucleus, giving off a smooth amount of spectrum, almost like a ladder, that an electron could be here, but it could also be here, and it could never be found in the middle. We call that being quantized. It has to be in a specific unit to exist. Now, how do you move an electron to a farther level? Well, you have to put a little bit of energy into it. So if we add a lot of energy, we could jump it up to this energy level. And as it falls back down, it's going to release a certain amount of energy. And so this is a visual or a model of what the Bohr model might look like. And so as it orbits around the center, if it receives a photon, it jumps to a higher level. If it gives off an equal photon, it'll drop down to a lower level. And so it's only existing in these quantized orbits. And this helped to explain spectra, because before the model was discovered or was put forth, people had started discovering spectra. They were looking into space, not with just a prism, but a spectroscope. So they were splitting the light into all of its different wavelengths, and they were starting to see these lines. So when you're looking at the sun, for example, which is mostly hydrogen, we saw these different series. So the Lyman series was developed by one scientist who was using spectroscopy, and he came up with an equation that explained what was going on, but you couldn't see this spectra because it was into ultraviolet. We also saw the Passion series that was showing the similar relationship, but this was in the infrared, and the Balmer series was seeing the same thing. And so what really he was explaining, let's throw the Balmer series up here, is that they were seeing these discrete units of light. And so where was that light coming from? If you look at hydrogen, well, you can see here as we move from this energy level 2 up to energy level 3, it requires a certain amount of energy. And as the electron falls back down, it's going to give off that energy. It's going to give off that light. And so the Bohr model predicted what these numbers were, and they fit perfectly with the numbers that we were seeing in the spectra. And so again, this only works for hydrogen, and so it's a good step model, or it's a good model to get you started on understanding how the atom is really put together. But did you learn the energy level structure of an electron in an atom at the appropriate scale being investigated? In this case, it's at these energy levels in hydrogen atom. I hope so. That's the Bohr model, and I hope that was helpful.